Calculus in the PM, AP Calc, Trapezoid Rule. The textbook has something else called the Simpsons Rule in there too, but it's not necessary as far as AP Calculus, the course you guys have called AB. Anyways, so if there's a question assigned that says use Simpsons Rule, we won't. We'd use the Trapezoid Rule anyways. I won't go into it any further than that. The Trapezoid Rule. So, pardon me, my little preamble I included here. Using integrals to find area works extremely well as long as we can find the antiderivative and antiderivative.
Mr. Flood, would you call the office, please? That's Mr. Flood, call the office. Thank you.
Sometimes the function is too complicated to find the antiderivative. At other times we don't even have a function, but only measurements taken from real life. So, if I had like a function for temperatures or something, daytime highs over a year, 365 days or something like this, it wouldn't be a perfect match for a cosine or something like that. It would be all over the map. I wouldn't have an equation for that function. So then, what we need is an efficient method to estimate area when we can't find the antiderivative. So we could use a left approximation, a right Riemann sum approximation, or a midpoint approximation, depending on the data given. This is also a good approximation. The skinnier, once again, the skinnier the strips, the more strips you have, the more accurate it is. But the trapezoid rule. What is a trapezoid? A trapezoid is this shape here, right? Yeah. Don't be hung up and do not memorize this formula, and I'll tell you why after. But that formula, it looks complicated. It isn't really. But if you want to approximate an integral from 2 to 7 or whatever, a to b, and it's partitioned into subintervals of equal length. Now this formula really only works when it's equal length. Typically though, on an AP exam, you would not assume that you have equal length subintervals. So we'll approach it from that. So we're really not going to concentrate on this formula too much, okay? It's not worth memorizing at all. But if you have equal length intervals, what is the length of the interval? You take the span, the top number minus the bottom number. So if you're doing the integral from 2 to 7, you go 7 minus 2 divided by the number of intervals that you have, right? We did this before 2 sections ago when we were looking at Riemann sums. Same idea there. You find out how wide each one is. That will give you equal intervals. By the way, a trapezoid approximation, if you knew the left, if you'd previously computed the left sum and then the right side Riemann sum, rectangular approximation method, anyways, and took the average of them, so you divide by 2, you will get the trapezoidal approximation. But really, what does it all come down to? Let's take a look here. We'll take a look at this one right here. If you basically take the starting point of that interval and the ending point of that interval and draw a line, that's going to form a trapezoid. Rectangular strip on the bottom, it looks like, but because the top is slanted, it's a trapezoid. If it is equal, sometimes that trapezoid really turns out to be a rectangle, right? That's an easy area to compute. But do you guys remember what the area of a trapezoid is? Yeah, it's probably been forever and a day. What do you say?
It's the height, like the second height. Mm-hmm. Like you find the average of the 2 heights.
Exactly. This trapezoid here has the same area as a rectangular strip with the average of these 2 top heights. Does that make sense? Basically, you take that little triangle and you toss it on here, and then you've got this rectangle. So basically, what you got to do is take the average of the 2 heights. You've already got the base, right? Area is base times height. Okay. So the area of the trapezoid. Now I'm going to show it like this. The area is. Now if I'm saying like from 0 to 1 or y0. Okay. go like this. Y0 plus Y1 divide by 2. Now that's going to take an average, as long as I show you what I mean by Y0. X. Now X would be like, I'm going to move this over a bit here. X is like the base. And so I could say the base. This is like Y0. This is the height, the high side. But all you need to think of is take the average of the two heights, find the midpoint height, not the midpoint X, and multiply it by the base width. Doesn't matter what width your strip is. And you do that for each strip. It's a bit of work. You add up that area of that strip and that area of that strip and so on. You notice that it's kind of weird though, but if this is your strip of width, whatever, X, the X width, and you have a negative number and a positive number, it doesn't seem to make sense when you join those lines, but that's the same, it'll use the same formula. Take the average of, like, this is -2 plus +3, comes out to be +1, divide by 2 is half, times the base. Okay? You still treat it the same way. This has the same area as, with the numbers I used, as a strip this high, is what you'd be saying. Okay? This is what you kind of have to think of or realize. But honestly, I don't do it that way all the time. I just take the average of the two heights for the first strip times the height, or the height. They're using H in a different way. I don't like using H as that variable, but their H is the base width, and I keep thinking of H as height. Then, so they're going through these, the average height of the next strip times the area of the base. I honestly think that this is the best form for what you're most likely to have, okay? Otherwise, this shows how you come up with the other formula, but put a star or a circle around this. This is what you'll use more often. This one seems like it's less work, but it's not very handy when you don't have any of the widths of the strips the same. So don't think of it that way, okay? And spend no time memorizing this. What the heck did I just accidentally do there? Okay. So let's just play around with some things and see how it works. Okay? Now we've all flipped. And we won't use the calculator program because I figured we won't do that and take the average. That should confirm your answer. Use the concavity of the function, though, to determine whether the approximation is over or an underestimate. Finally, find the exact value to check your answer using your calculator. Okay, so what we're going to do is 4 intervals, a trapezoidal approximation. We should know the general shape of this function. I hope you do. Sideways, half of a sideways parabola, right? Starts at 0. Okay, there's my general shape. I don't know if my glitch is going to work. So here's 0, 4. Okay. I know you guys know a few things from this. The easy values to come up with. Lessons. 1, 2. Oh, this is so tight in the board here. 2 here. Okay. 2 and 4 is an ordered, 4 comma 2 is an ordered pair. 1 comma 1 is an ordered pair. 0 comma 0. Radical 2 and radical 3 are non-fraction numbers. I can't even think today. They're real numbers and they're irrational numbers, yeah. But we don't really need to know too much about that. Let's think here. I could apply this formula, but I'd like to do it on first principles. We have 4 intervals, and it works nicely from 0 to 4. Many blessings. So this formula works, no problem, but like I say, spend no time trying to memorize that. Don't use it. So what we're going to say is the trapezoidal area. TA or T if you want. In this context, I'll know what you're talking about. To approximate that, you're going to do this. You imagine a trapezoid from here to here, trapezoid from here to here, trapezoid from here to here, trapezoid from here to here. Okay. You got 4 strips. The width of each strip is 1, right, in the x-axis. So I'm going to write that down, though, the width times. Now the left-hand side height is 0 for the first strip and 1 for the other side, right? Now I'm going to write this down this time because I'm just showing you this, but I wouldn't normally. 0 plus 1 divided by 2. Add that to the area of the next strip. It's got a width of 1, a height of 1, plus root 2 is the best I can do, isn't it? Like 1 point. I'll call it root 2 over 2 plus 1 times 1, look, root 2 plus root 3. Sorry. I'm writing too big. Root 2 plus the height on the other side, root 3 divided by 2. And then lastly, root 3 plus root 4, and I've got to squeeze some stuff in. That I will. I can do this. I didn't put 1 times there in that last one, and I won't here, but you're really multiplying 1 times there. And if it was any other number, I'd have to include it. Root 3 plus 2 over 2. Okay. That doesn't simplify a heck like easily or anything like this, but if you do the arithmetic, this is an expression you can work with, right? Does that make some sense? Now, of course, you probably would have started this out right off the bat and said this is half. Everything else, though, would be fine. I don't need you to do anything further on this. If you needed to work with things, everything's out of 2, basically, right? 1 out of 2 plus this group of 1 out of 2, this group of root 2 out of 2, root 2 out of 2 again, root 3 out of 2, root 3 out of 2, added to 2 out of 2 to 1. And you could group your radicals and group your numbers. I don't care. But do you guys see how that works? Okay. Just because we can't get you could use an answer, I guess. It'll come out to be, if you used a calculator, 5.14. If you want to get a calculator involved there, you could come up and you'd get 5.1. Well, let's just think this through. What is this? I said this was 1/2 plus another group of 1 out of 2, so that's a total of 1, right? And do you see how this tail end here, 2 out of 2, that portion will give me 1? So 2 plus 2, or 1 plus 1 is 2 for the whole number, for the integer portion. Then I've got a radical 2 twice out of 2. So I'll add up to radical 2. The radical 3 out of 2 plus another radical 3 out of 2, radical 3. If you didn't have this if you had this without a calculator, that would be the exact value. If you enter 2 plus root 2 plus root 3, you'll get 5.1463. So it's approximately 5.63. Okay? The exact value, if you used a calculator or if you did the antiderivative, you should be able to do the antiderivative, actually. Actually, let's do this antiderivative because we need the practice. I'm going to write this, though, as x to the 1/2 dx. What is an antiderivative that works? I say 1 possible antiderivative, because we usually use the simplest. Give me an antiderivative for x to the 1/2. Yep.
2/3 x to the 3.
So I think what he's, the way you probably went about doing it, the way I do it is, I think backwards from doing a derivative. I increase the exponent, 1/2 plus 1 is 3/2. And then instead, I bring down the reciprocal, 2/3, right? That's what we have. Now, if you find it easier, going from 0 to 4. Some people might want to write that like this. 2 x cubed under the root, or take the root and then cube it. Either way works. That's one possible, that's the same expression, right? If that helps you. So then I plug in 4 and I plug in 0. So I'll keep it this way though. 2/3. Now I plug in the square root of 4, well, I'll just put it like this. 4 to the 3/2 minus 2/3, 0, 3/2. Now, 4, the square root of that is 2. Cube that, it's 8. 8 times 2/3 is 16/3, correct? Minus 0. So 16/3 is the exact value of that. Now, the arithmetic, you would be actually, on the non-calculator section, you should be able to do arithmetic like this. This is about the level of most of the arithmetic on an AP exam. You're talking about square roots with 4s and 16s and 9s and stuff like that, okay? So, but you do have to know your stuff, especially when you have negatives and positives combined with fractions. They're not crazy. You're not going to have fractions out of 57 or stuff like that. Okay? And 3 goes into 16 5 times, and 1/3. 5.3. Hey, this isn't a bad approximation, the blue stuff. It's an underestimate. We could see, because this is 16 out of 3 is 5.3 repeating, right? Because part of the question was, is this an over or underestimate? This is an underestimate, but without computing the exact value, could you have reasoned that this is an underestimate? Yeah, because this is concave down, right? The blue function. And when you're taking what I have in green there, it's always underneath the curve, right? So you know you're going to be slightly underneath. Okay? So that's how that works. Using a data table then. This is where the trapezoid rule is quite useful. Like I said, in science, physics, biology possibly, chemistry, you sometimes have data sets you don't have a function for. And I'm only using those examples because that's what I work with. Financial models, I'm sure too you could do this. An observer measures the outside temperature every hour from noon until midnight. So, and the following temperatures are recorded in this table. Now, as soon as I see n for noon, I'm thinking this is 0, 1, 2, 3, 1 hour later, 12. Okay? I'm just jotting that down there so I can make sense out of this. And then the temperatures are in Fahrenheit, because that's 63. Okay. And we see what happens. What's the average for the 12-hour period? Average temperature. Now look at this. This is given like x and y. Or the function is temperature. Now, don't be tempted to just add up 63 plus 65 plus 66 to find the average of 12 numbers. This is the function of an average. So, solution. We're looking for the average value of a continuous function. Because even though we don't know 63 to 65, it must have increased from 63 to 65. It could have been like this. It could have been 63 to 65, a straight line. We're going to approximate it with a straight line. Or, I made too much of a circle there. It could have been like this, but this is a continuous function. So when you're taking the average value of a function, you have to use this the other day. What does this mean? This really means the average value, the average height of that function. This is 1 divided by the span, right? B minus A, the base. And this is the area. This is really just the area formula rearranged. And I showed you that the other day to find average value of a function. Now, how do we do that? Well, we've got to approximate this, and let's do this as a separate step, because we don't have an actual function. So we're going to estimate using the trapezoid rule. You could use, if you were asked to do something else, the midpoint rule, left or right, but it's going to take a bit of time. So, a shortcut on this, though. Do you notice that the width of each interval is 1? So, 1 times anything, you should be aware that you're actually multiplying base times height, average height. But since it's 1, you don't have to write it down each time if you're using that common sense, okay? So I'm going to use a trapezoidal estimate, so I'm going to use a T for the area that I'm estimating. So I'm estimating the integral. And then I'll come back to that formula. And I'm going to use a trapezoid to estimate this. Now, I'll put the first one as 1 times, but do you really have to say 63 plus 65 divide by 2? Or can you do that in your head? Some of these you can, I hope. You're looking for the average of 63 and 65, that's 64, ain't it? Taint. Okay, so 1 times 64 plus 65 and 66, 65 and a half, plus, you got to do this many times, but 66 and 68 is 67. 68 and 70 between 3 and 4, 69. Double check my math too. 70 and 69 is 69 and a half. 69 and 68 is 68 and a half. So I'm averaging just in my head. The average of 68 and 68 is 68. I'm going to run out of space. 68 and 65. 66.5. And here, I'm just moving here. We're 65 and 4 is 64 and a half. 64 and 62 is 63. 62 and 58 is 60. Oh, I missed one. 65 and 60. Okay, where was I? No, I didn't. Okay, it's 60. It's easy to miss one, though. Oh, that damn thing. Yeah, 58 and 55 is 56 and a half, right? Sure. Now, does everybody get how I wasn't literally adding 55 plus 58 divided by 2. I just know the average is the center number between two things, right? And we know that each one is 1 times for the base, so there's no use of writing it down. You don't actually have to use a complicated formula if you understand these things, right? Average height of the strips of the trapezoid times the base. And luckily we had the base the same all the time. So this is just arithmetic, and if you add it up, you'll get 782. Now this is something you can do with a calculator. You would be expected to have a calculator on a question like this. But I mean, I didn't use a calculator for the first step. I think it's slower to use a calculator for the first step, right? The biggest danger is that you miss a whole interval. I thought I did for a second here. So when you do a question like this, make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Make sure you have 12 values there. Maybe tick them off as you do them. Maybe even it would be a good idea to just do your arithmetic under here and put your 64 right there, and then so you know for sure you haven't missed anything. 782 is that. Now I've got to get back to the problem. My average of this function, the average temperature. So I'll say the average of the temp. This is confusing. I was going to use T, but I used T for trapezoid approximation. Is equal to 1 over B minus A. In my case this time, B minus A is 12 minus 0, right? From noon to midnight, 0 to 12. Okay, so 112. I have approximated that integral using an estimate. I use the trapezoidal estimate, 782. And you'd have a calculator. And to 3 decimal places at least, 65.167 degrees Fahrenheit.